What is time? One possible answer is this. Time is what keeps everything from happening at once. Consider your desk in your classroom. Last year, a different child was sitting there, and next year, it will be someone else. Because the desk exists at different times, it can be used by different children without having them collide or merge, which would be quite inconvenient, not to mention painful. In 1905, a physicist named Albert Einstein discovered that time and space are linked together in a fascinating structure called spacetime. Within spacetime, time is a dimension, that is, a line that goes from the past to the future and that can be used to indicate when something happens. Because space has three dimensions, width, length, and height, time is the fourth dimension of spacetime. If we put one of the dimensions of space along the bottom of the screen and the dimension of time along the side, we get a spacetime diagram where we can show all at once what happens at different positions in space and at different times. For example, on this spacetime diagram, you are standing still and a giant snail is moving toward you. One of the most surprising things that Einstein discovered about spacetime is that the faster you move through space, the slower time flows for you. You don't notice this effect in everyday life because you don't move fast enough. When your speed is zero, the flow of time is normal. As your speed increases, time slows down more and more, but the effect becomes important only when your speed gets close to the speed of light, which is very fast. At the speed of light, you could cross North America 60 times in 1 second. Imagine you have a twin. One day, you find an abandoned flying saucer with 1 year of supplies in it, and you decide to take a 1-year trip. You move away from the Earth at 99% of the speed of light for 6 months, turn around, and travel another 6 months at the same speed to get back. At the end of the trip, you are 1 year older, but 7 years have elapsed on Earth. Your twin is 7 years older than when you left. What happened? At 99% of the speed of light, time slows down 7 times. Let's look at the spacetime diagram. Your twin took 7 years to get from point A to point B in spacetime, but you only aged 1 year going from A to B. In the saucer, the slowing down of time made everything slower. Your watch, your heartbeat, your brain functions, so you didn't feel that time was any different than usual. But from the point of view of the Earth, you time traveled to the future at 7 times the usual rate. In real life, the fastest space probes we have ever launched travel 10,000 times slower than light, so the slowing down of time remains very small. By using enormous machines called accelerators, we are able to make very small particles travel at speeds that are close to the speed of light. In one experiment, unstable particles called muons were produced. At rest, these particles last for a fraction of a second before disintegrating. We made these particles travel at 99.94% of the speed of light, and they survived 30 times longer, which is exactly what Einstein predicts. At 99.94% of the speed of light, time slows down 30 times. In the largest accelerators, we can make time slow down more than 100,000 times. For particles that travel at the speed of light, like those of light itself, the slowing down of time becomes infinite, so time simply stops. But if time slows down more and more the faster you go, and stops for particles that travel at the speed of light, could it flow backward if you travel faster than light? Well, in spacetime, faster than light travel could in principle lead to backward in time travel, because of another effect discovered by Einstein, something even more mind-boggling than the slowing down of time. It turns out that the answer to the question, what is going on right now elsewhere in the universe, depends on your speed. Because of this effect, people who do not travel at the same speed do not agree on what constitutes the present moment throughout the universe. If you could hitch a ride on an alien mothership that moves away from the Earth at less than the speed of light, then launch yourself from the mothership toward the Earth in a spacecraft that moves faster than the speed of light relative to the mothership, you would still be traveling toward the future from the point of view of the mothership, but, believe it or not, from the point of view of the Earth, you would be traveling toward the past. But does that make any sense? To travel somewhere, that somewhere must exist. If you can travel to the past, this means that the past must still exist. Well, in spacetime, the present and the past coexist in the same way that left and right coexist, so the past still exists somewhere, or should we say somewhen, along the dimension of time, and by traveling faster than the speed of light, you could get there. Oh, but not so fast. There's a little problem. According to Einstein's theory, just to make your spacecraft reach the speed of light, you would need to get an infinite amount of energy, which is, of course, impossible. And to travel faster than the speed of light, well, you would need more than an infinite amount of energy, which is more than impossible. Or is it? The thing with science is that we can never be sure that our current theories are the final say on any matter. We know that it is possible to travel forward in time at a rate that depends on our speed. But will it be possible one day to travel backward in time? Nobody knows, yet, but surely time will tell.